Hello everyone, my name is Chirag Patil and welcome back to my YouTube channel. So in today's video, we will understand how support vector machine regression works. Right, so before start, if you haven't seen my support vector machine classification video, I would recommend that please go and check it out first. It will help you to understand support vector machine regression settings because in that I had explained you support vector machine classification in geometric and mathematics behind it, right? So let's start. So let's understand. I have only one feature, let's say x, and I want to predict y in the regression setting, right? Y could be any real number, okay? So in support vector classification, we had seen that we are maximizing a margin which will classify our data point, right? So we are just maximizing margin between p plus and p minus, right? So we are doing similar thing here. Let me draw and I will explain you what we are doing here. So let's say I'm assuming that you had seen my support vector machine classification video, right? So let's see. Let's say this is my one plane, okay? And this is my second plane. Both are parallel. And my best fit line, so it is only one feature, right? So we are just doing line here. So let's say my best fit line will be this, okay? Let me draw it darker. Let's say this would be my best fit line, okay? So just assume, let me select a pencil, okay, yeah. So let's assume this distance and this distance is same, okay? If the both plane are equal distance from this my actual plane, right? Okay, so let's understand here. So in SVM we had this optimization problem, right? Let's say, let me write for SVC, which is basically classification. We were finding optimal W, which will minimize plus C times 1 by n 1 to n eta, right? So this was in the support vector classification setting, okay? So we had seen that to maximizing this margin is equivalent to minimizing norm of W divided by 2, right? So here our constraint was that yi into W transpose xi is greater or equal 1 plus, greater or equal 1 minus eta time, right? Where eta would be error and yi into yi belongs to minus 1 or 1, okay? So this was a support vector classification. So now let's see, in the regression setting I want to predict a value. We are not classifying here, right? So let me write the equation first and I will explain what we are doing in SVR, support vector regression. So in regression we will find optimal W, which will minimize norm of W divided by 2. Basically we are maximizing this margin, right? Plus, let's say C times 1 by n sigma I is equal to 1 to n absolute value of eta. Let me rewrite absolute value of eta, okay? So this is the cost function or our optimization function for support vector regression. Here the catch is constraint is yi minus W transpose xi will be greater or equal, will be less or equal 1 plus eta, okay? So let's understand what is here eta and what we are doing, okay? So basically if you see in the regression setting we don't use any classification metrics, right? We use like, let's say MSE, mean square error, or mean absolute error, right? This kind of errors we are used when we are using a regression setting. So here if you see, we need to check let's say what is my predicted value. This is W transpose Xi would be predicted value, right? And Yi will be my actual label. So what is the difference between my predicted value and actual value here? We are considering absolute value. So let's say my actual value is here, okay? My actual value is this point and I am predicting here, right? Because in regression we are predicting the point which will on the line, right? So basically let's say for any x, okay, so for any x, let's say x is here, right? So I will predict the y according to here in one feature settings, you can say, right? Basically we are doing this thing. For this x we will find the y value here, right? So I am finding this y hat here and my actual value is his. So my error would be this, right? This much would be my error. So let's say I have to, let's say the y is equal to 50 is actual point and I am predicting 45. Then 5 would be error, right? Simple. So here what we are saying, it should be less than or equal to 1 plus eta. So we know we are using this distance, right? Let's say it is like W transpose X plus B is equal to -1 and this is W transpose X plus B is equal to 1. But in regression setting we don't have any -1 and +1, right? We are just calculating the distance, so both would be at one distance if you take absolute value of this, right? Simple. Okay, so this would be the error, right? So if I have less than 1, then I can say I am predicting very well because my predicted value and actual value its difference is less than 1, right? Because if let's say any point is belonging in this region or any point is in this region, actual value, right? Consider this red point and I am predicting any value on this line, right? So the difference between predicted and actual value will be less than or equal, right? Less than or equal to 1. But let's say my actual point is here, right? And I am predicting this value, right? Let's say this y, right? So my difference will be larger than 1, right? It would be more than 1 because from this to this it is 1 and it is 1, right? If I go far away from this plane, right, it would be greater than 1. Then I would say the distance of this distance is my eta, right? So what we are saying, we need to minimize this function, okay, where here we are considering eta because if let's say you are predicting something larger value, let's say my actual value is 50 and I am predicting 55, then it would be -5, right? But we are just calculating distance or we are calculating the MAE here, I would say, then it would be positive. So basically we have error of 5, right? So what we are saying here, that my yi minus W transpose Xi should be less or equal 1 plus eta, and here eta is this error and 1 is this, right? If it is less than or equal to 1, we are finding best result. But we are if you consider this, right, let's say yi minus W transpose Xi less or equal 1, then it will be like hard margin SVM kind of thing, right? For we will not get for every point that yi minus W transpose Xi is less than or equal to 1. So right. So in a SVM, to achieve soft margin SVM, we introduce this error term here, right? Same in regression, we are using this eta, which is basically a distance of a point or actual value, we can say, from this our marginal planes. Let's say P plus or P minus. In the SVM setting, we call this P plus and P minus, right? So this is about support vector regression. So constraint will change, otherwise everything is remain same, right? We are finding a actual line or plane which will maximize this P plus and P minus, right? So this is all about support vector regression, right? In next video, we will implement support vector classification and regression from scratch using Python. Thank you.